Hey guys, today we're going to talk about percent composition and how to take a molecular formula and turn it into a percent composition. So this is Unit 4, 10.3 Notes Part 2. Today you're going to need a calculator and your periodic table. So if you don't have either of those, just pause the video, make sure you have both, and then come right back. All right, so here's the thing you have to remember. Atoms are so incredibly small. Like we talked about at the beginning of the year when we talked about the structure of an atom, how unbelievably small an atom is. It's so small, the human brain really can't process how small. So we can't really study one atom at a time because we can't do much with one atom. Now, physicists can because they're all sorts of fancy, but for us chemists, we like to see reactions happening. So scientists work in terms of moles. And no, not the animal a mole, but it is funny to think of it like that. So moles are a chunk of particles, a very specific amount of particles. And when I say particles, I mean the pieces that build up that substance. So if it's like calcium, pure calcium, then that's going to be made out of atoms because an element is made out of atoms. Versus if it's water, H2O, that's going to be made of molecules, right? Because that's a group of atoms together. So whenever you have a mole, you're talking about 6.02 times 10 to the 23rd particles. I want you to think about that for a minute. That's 602 with 21 more zeros after it. That number is so big. If you tried to count from 0 to 6.02 times 10 to the 23rd, you would die long before you got anywhere near that number, even if you were counting one number a second. That's how giant that number is. So when we're talking about 1 mole of something, it's a bunch of particles, but it doesn't necessarily turn into a bunch on the human scale. It's because you have a bunch of really small things. Now, when we're talking about moles, it's really important to know how much of something is 1 mole. So you can say, oh, look at this substance. It has 6.02 times 10 to the 23rd particles in it. Okay, so what we use is this thing called molar mass. It's really easy to measure because mass is grams. It's what you put on the scale. So the molar mass of a substance is the mass or how many grams 1 mole of that substance has. And as you might guess, the trick is on the periodic table. The mass in 1 mole of an element is found on the periodic table. It's equivalent to the average atomic mass in grams. So go ahead and take out your periodic table now because we're going to use it and we're going to find some average atomic masses. So let's say I wanted to know what's the mass of 1 mole of carbon. Then I take out my periodic table and I find carbon. So carbon is atomic number 6. It's over in the top right side. Remember, this is the number of protons or electrons, but this has to do with the mass. So 12.011 is the average atomic mass. That's the mass of 1 atom in atomic mass units, but when we bump it up to the scale of moles, it's also the mass of the grams in moles. Now I want you to cut it off after 1 digit. Don't forget to round properly. So if I'm cutting it off after 1 decimal place, I'm sorry, you look to the number after. 1 doesn't bump it up, so it says 12.0. How about 1 mole of magnesium? So I want you to freeze this video, find magnesium, and see if you know what the molar mass of magnesium is. All right, if you have 1 mole of magnesium, exactly 6.02 times 10 to the 23rd atoms of magnesium, and you put it on a scale, you'll get 24.3 grams of magnesium. Same thing for copper. I want you to freeze the video and find what you think the molar mass of copper to be. All right, hopefully you found it. If you didn't, freeze the video. And what you should have gotten is 63.5 grams of copper. So if you didn't get either of those, then take a minute and ask me or whoever your teacher is a question. Otherwise, we're going to move on. So what we did before was really great for finding the molar mass of an element if you have something that's a pure element, purely found in the periodic table, but most things in life are not pure elements. A lot of things are compounds, and compounds we talked about in the last set of notes when we talked about water. Remember, water is always H2O because compounds are made out of a set ratio based on the molar masses of the elements that make up that compound. I always have 2 grams of hydrogen for every 16 grams of oxygen in H2O. How did I get that? Well, the molar mass is found by this. if you have a compound, then the subscript is saying how many moles of that times the molar mass of that element. Make sure this is in parentheses, and then add it to your next element. Same thing, in parentheses, subscript times that element's molar mass. And if you have more than 2 elements, you do it again. If you have like 6 elements, you're going to do it 6 times. It just depends how many elements you have. Some compounds are only going to have 1 element. Like if you have a diatomic, like oxygen is O2, so that's just going to be 2 times 16, and that's it. But if you have water, H2O, it would be 2 times the molar mass of hydrogen, and parentheses, plus 1, because H2O, oxygen, doesn't have a number, so you know it's 1, times the molar mass of oxygen. Let's do some examples. And the formula is right here, but you should have it in your notes. So 1 mole of calcium chloride, CaCl2, you have to remember that if you have 1 mole of calcium chloride, since 1 formula unit of calcium chloride has 1 calcium to every 2 chlorines, then it's also that many moles. So in 1 mole of calcium chloride, that can break down to 1 mole of calcium atoms and 2 moles of chlorine atoms. So the molar mass is, we use our formula. So our first thing is calcium, which would be 1 calcium plus 2 chlorines. And then plug in your numbers. So 1 times 40.1 is calcium's molar mass, plus 2 times 35.5, that's chlorine's molar mass. And this is going to give you 111.1 grams for every 1 mole of calcium chloride. Sometimes you'll refer to this as 111.1 grams calcium chloride, but know that that's talking about 111.1 grams of calcium chloride for every 1 mole of calcium chloride. So if you have 1 mole of calcium chloride and you put that on a scale, you're going to get 111.1 grams of calcium chloride. Let's do another example. If you have 1 mole of ammonium sulfide, what's that made out of? All right, so first let's talk about nitrogen. In 1 mole of ammonium sulfide, or 1 thing of ammonium sulfide, how many nitrogen are there? I'm going to say there's 2 nitrogen. And you're probably like, whoa, Mrs. Dominiak, that's totally not true. There's no subscript after nitrogen. Gotcha, I know that means 1. You know what, you'd be right. But this subscript outside of the parentheses means there's 2 of everything in here. Boom. Just science to you. Okay, so you have technically NH4, NH4S, meaning you have 2 nitrogen. All right, so remember this 2 essentially gets distributed in, right? You multiply it by whatever subscript you see, meaning how many hydrogen do we have? Well, I have NH4, NH4, 4 plus 4, or you can think of it as 4 times 2. So I have 8 moles of hydrogen, and sulfur is not affected by this 2 because the numbers always go backwards. So 1 mole of sulfur. All right, let's figure out the molar mass of ammonium sulfide. So you have 2 nitrogen and 8 hydrogen and 1 sulfur. Now look at your periodic table, plug in the numbers you find for each element. So I have 2 times 14 plus 8 times 1 plus 1 times 32.1. These are the molar masses of that element pulled from the periodic table. Now you plug this into your calculator and you get your final answer. So make sure you plug it into your calculator and you're getting what I get. That way you can ask questions before it's for a grade. All right, you should have gotten 68.1 grams, and that's 68.1 grams of ammonium sulfide in every 1 mole of ammonium sulfide. Now I want you to do these on your own. So find the molar mass of nitrogen, diatomic, remember, so nitrogen on its own is N2. Dicarbon tetrachloride, magnesium carbonate, and strontium hydride. So freeze your computer because I want to see the math of it on your notes. So you need to do it on your own and make sure you get the answers I get. All right, so here are the answers you should have gotten. 28.0, don't forget that 0, grams of nitrogen, 166.0 grams of dicarbon tetrachloride, 84.3 grams of magnesium carbonate, and 121.6 grams of strontium hydride. Please, 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 now's the time to ask a question. Make sure you did all the work and you got all those answers right. If you didn't get any of them right, then ask me a question. All right, so for now, I'm going to assume you got them. We're going to move on. So when you know the molar mass, that allows you to find the percent composition regardless of the sample size. So first I want to show you the equation we did last notes. So if you remember, don't write this down, you already have this, we said the percent composition is going to be the mass of that element from the sample divided by the mass of the compound times 100. But now we can restate it. So this is what you want. When you're figuring out percent composition just from a chemical equation, you'll do the mass that came from the element in the compound divided by the molar mass of that whole compound times 100 equals percent composition by mass of that element. So let's do some examples. All right, what is the percent carbon in propane, which is C3H8? Now, if I look at this, I'm going to say the mass of the element in that compound. So how much of that molar mass comes from carbon? So I have 3 carbons. So 3 times the mass of carbon is the mass that comes from carbon in 1 mole of my substance. And I divide it by the whole thing, 3 times carbon plus 3 times hydrogen. So this is the molar mass of the compound. So mass that comes from carbon in the molar mass, total mass, molar mass, times 100. So that's going to give you your percent carbon. We've got 3 times 12 on the top because carbon's mass is 12, divided by 3 times 12 plus 8 times 1. Be absolutely sure that everything on the bottom is solved or put in parentheses if you're going to plug this into your calculator. If you don't have these brackets on the bottom, these extra parentheses, then it'll totally mess up your answer because the order operations will be all messed up. All right, so don't forget to times by 100. You'll get 36.0 divided by 44.0 times 100. So this is 81.8% carbon. That means in any sample of propane, forever and always, 81.8% of it is always going to be carbon. And then we can do like we did before, like if you have a sample of 352 grams of propane, how much of it is carbon? And you say, okay, 81.8 divided by 100 times, I think I said 351 grams, I don't remember, whatever it is of your sample size. So now you can use those equations from before. All right, we're going to do one more example. What is the percent oxygen in gallium carbonate? All right, so same thing. First, we figure out how much mass in 1 mole of this comes just from oxygen. How many oxygen do we have? Well, we have 3 in each carbonate, but I have 3 carbonates, so it's 3 times 3 or 9. So I have 9 oxygens divided by 2 galliums, 3 carbons, and 9 oxygens times 100. Let's plug in our numbers from the periodic table. Oxygen is 16, and gallium is 69.7, carbon's 12, oxygen 16. Don't forget to times by 100. Now we can put this into our calculator. So if I simplify the top, I'll get 144.0 on the top. The molar mass of gallium carbonate is going to be 319.4 times by 100. You should get 45.1% oxygen. All right, so hope you are doing well at percent composition. Now is the time to ask a question if you have it. Otherwise, I'll see you in the next set of notes.